Okay, so I ran across somebody who was talking about these ultra duster, industrial strength. What is this? Canned air, right? It's an air duster or canned air. Is that what this is? Canned air? Is it? Is that air that's in that can? Well, good question. I'm a little irritated every time somebody calls something like this canned air or compressed air, because this is absolutely in no way air that is in these things. Right? So when you buy Dust Off or whatever brand it is, do not think that this is air, because it's not. So, what is it if it's not air? Well, the stuff that is in here is chemically what a lot of us would refer to as Freon, refrigerant. Okay, it's a fluorinated hydrocarbon that is in these cans. So this particular can contains 1,1-difluoroethane. What is that? 1,1-difluoroethane. Easy for me to say, right? And that molecule is nothing more than two carbon atoms, single bonded together. Over here we got our hydrogen, 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 and then we have two fluorine atoms. So ethane is C2H6. That's the chemical ethane. What we've done to ethane is we have replaced two of the hydrogen atoms with fluorine atoms. And they sit at the 1,1 position in this molecule on carbon number 1 and or carbon 2, depending on how you flip it. But those fluorines are very, very special. And this gas has properties to it that make it suitable for using in these air dusters. And air duster. Gas duster is probably the right term for this. Because it's not air, it's a gas, but it isn't air. So, 1,1-difluoroethane. This gas is also commonly referred to as R152A. In the HVAC industry, that's what they would call this. Some of these dusters use a gas called R134A. And R134A basically adds two more fluorines. Actually, I think it does it this way. Two of them are over here, and two of them are on that side. Very similar gases, just one has two fluorines, one has four. The 2-fluorine version is the basic economy model that's cheap. So this is a cheapo Walmart air duster or gas duster. It's got the cheap 2-fluorine version. You can buy the more expensive 4-fluorine version for a little more money. The advantage of 4 fluorines is it reduces the flammability of this chemical. I mean, this gas is not very flammable to begin with, because fluorine does not like to burn. Fluorinated compounds don't like to burn very easily. And when you increase the amount of fluorination, the gas becomes less flammable. It's pretty much impossible to ignite R134A with 4 fluorine atoms. Whereas you can, if you really, really try, you can ignite 152A, but it takes a lot of work. It takes a lot of coaxing to get it to light on fire. So, what else is so special about these gases versus air? Probably, actually, the big reason why they use this stuff is because you can't stuff enough air into a can like this to make it effective. So the difference between these two gases and regular air is that these can be liquefied under pretty reasonable pressures. So I can get myself some R152 or R134 dye or tetrafluoroethane and start pumping the gas into this can. And once I hit, something like 120 psi in the case of 134, or maybe like 80 psi in the case of 152, the gas will just start condensing into a liquid. So we go from gas to liquid. That's very, very important in one of these dusters. So the best analogy that most people are probably familiar with is a propane tank. So you got your propane on your grill, that little tank, and that tank contains quite a bit of propane. Usually they're 20-pound tanks, about 4 gallons or 5 gallons of propane that's in there. And a propane tank, basically, we'll draw one here. We'll play Hank Hill for a bit. Okay, you got your valve, you got your withdrawal from the propane tank. The gas comes up and it goes out, and you got your hose, and you've got your regulator valve here that regulates the flow of the propane to maintain the proper pressure going to the burners on your grill. Inside the propane tank, you think, oh, propane gas, it's a gas grill, right? Well, the grill burns gas. The material going out to the burners is a gas, meaning that it's molecules that are very far spaced apart and that are zinging through space. But in the tank, you actually have both liquid and gas. So let's say you got a half full tank of propane, or approximately half full. So down here, it's all liquid. It's like water. It's liquid propane. Up here, it's all gas. So when you start cooking on your grill, this gas starts to move out and go out to the burners, and the burners then consume the gas. And what that does is, so a chemical like either difluoroethane or propane has what's called a pressure-temperature curve. Saturation pressure versus temperature. So if the temperature outside today is 70 degrees, the propane tank is probably about 70 degrees. And the gas pressure inside the tank above the liquid is completely dependent on this pressure or temperature when liquid is present in the tank. So if we have liquid propane, even if it's a single milliliter of liquid in your propane tank, that pressure in that tank is completely dependent upon the temperature of that liquid. And that's why when you're using a propane tank, it just runs out. It just suddenly, poof, it's done. Because you've basically exhausted the liquid all the way down. All the liquid has evaporated into a gas. And once there's no liquid left, the pressure in the tank will just start plummeting. So pressure versus time. It just goes to nothing very, very quickly. And that's what would happen if we had put air into our duster. If we took this can, this is a thin little sheet metal can, it has to be cheap to manufacture these. You could probably put about 150 psi of pressure in this can. And as soon as you start blowing off the air, that pressure will start dropping just like this. So a full can, you give you 150 psi. But within less than a minute, you're going to be down to 0. And gas has a very, very low density compared to liquid. So if we stuffed 150 psi of air pressure on this can, that's about 10 atmospheres. So the atmospheric pressure is about 15 psi. We put 150 in and we got 10 atmospheres. So this can has a volume of 374 milliliters. So 374 times 10 gives us 3.74 liters, or just under a gallon. Almost exactly a gallon. So the most air you can put in this can is, here we go. So this bottle here is 2 quarts. 2 of these would be 1 gallon. So I can only compress air into this can at 150 psi that's equivalent in atmosphere volume of 2 of these bottles. That's really pitiful. That's really highly inefficient. You would be very disappointed if you paid for a product and that's all you got. And that's what would happen if we stuffed air in here. But what if we kept, but can you liquefy air? Well, yeah, you can. But the pressures that you need are either enormous, completely impractical. There's no man-made material that can withstand that pressure. Or you need to refrigerate the air down to a very, very low temperature. And then you can get it to liquefy. Except, then your can is going to absorb heat from the room, and it's going to go back, heat back up, and the pressure is going to build, and it will blow the can up. You can't liquefy air and store it in a $2 can that you can be sold at Walmart. Now, theoretically, I could sell you like a little scuba tank, pumped up to 4,000 psi, hundreds of atmospheres. But the can would be wildly expensive and uneconomical, and would be a shame to just throw in the trash when it's empty. So we don't use air for that reason. You just can't get enough air molecules in here. But if you use something that can be turned to a liquid that then will boil off to a gas and give you gas when you need it, now we're talking. So we could use propane in these cans. What's the problem with that? Well, that's a lawsuit waiting to happen, right? It would be fun. You take your propane, your lighter, and you put it here, and you shoot the thing, and you get a flame about 6 feet long. Or people spray it next to the electric switches and motors and whatever ignition sources they have available to them, and suddenly we have a little flash fire on our hands from the propane that somebody blasted off out of one of these cans. So the alternative is you use difluoroethane or tetrafluoroethane, which is resistant to ignition. Well, okay, great. It sounds wonderful, right? Well, there's problems with these gases too. So these here are absolutely horrible for global warming or climate change. These are awful. These are one of the worst consumer products out there for the environment in terms of the greenhouse gas problem. And why is that? Well, difluoroethane, all right, which is the cheapest gas, it's the one that's in here, has what they call a global warming potential, or GWP, of about 130 or so. I think it's like 134 maybe. That's just a guess. It's in the hundreds. And then tetrafluoroethane has a GWP of 1430. It's about 10x, right? And what do these numbers mean? Okay, so what this is this is the amount of greenhouse effect you get from this gas in relation to carbon dioxide. So we think about global warming, we think about greenhouse effect, we think carbon dioxide from burning fuel. Okay? Carbon dioxide has a GWP of 1. It's the standard value. These gases are much better at insulating, so they give us much higher GWP. So once this gas is released to the atmosphere, it mixes into the air. And like I said, these are not flammable. They're pretty much unreactive. So they just hang out in the environment. They don't really go away very fast. It takes like hundreds of years for these gases to degrade in the atmosphere. So they just hang out. And while they're there, they take infrared light radiating off the surface of the earth, strikes that gas molecule, and it gets excited. The same exact way that a water molecule in your TV dinner will get excited when you put it into the microwave oven. Radiation hits that, and it causes it to vibrate. And that vibration is then heat. And it heats up the atmosphere. So it's like throwing a blanket over yourself when you're cold. It keeps the heat from radiating off into space as easily. It's insulation. So it insulates the earth. That's what greenhouse gases do. And these ones are pretty effective compared to CO2. So what that means, so this gas duster contains 340 grams of this one. So how much CO2 would have to be emitted to be equal to that in terms of greenhouse effect? Well, it would be 134 times 0.34 kilograms. So it's like about a third of a, divide that by 3, I don't know, it's like 120, I don't know, 40 or 50, not quite 50, 40 and change kilograms of carbon dioxide. So we know that 40 kilograms is something like 90 pounds. When you burn 1 gallon of gasoline, you make about 18 or 19 pounds of CO2. So this container is the same global warming effect as burning like 4 gallons of gasoline. Wow, you know, that's a small little container. And that's 4 gallons of gas. And if you buy an air duster that's this guy, it's 40 gallons of gas. Because he's about 10x stronger. So these pack a punch in terms of greenhouse effect. So what I like to do is avoid these and use real compressed air, which I have the luxury of doing so we don't break anything. This is an air hose. We got a compressor, 2 compressors in the back over there, and we can make our own compressed air and not have to use these crazy high gases. The other thing, and probably for most people, more importantly, is these things are expensive. I mean, this thing was probably $5 and I bought it years ago. If you go to the store to buy one of these now, you're probably looking at $10 or so for some gas. Whereas an air compressor, you can buy an air compressor at Harbor Freight for less than $100, a little pancake compressor, and pay for itself over a few of these cans. And you're not contributing to all this greenhouse effect. You're using a little bit of electricity, but it's nothing compared to this nonsense. So these gases, especially this one, the tetrafluoroethane, the R134A, are also used as refrigerants, hence the term Freon. Most of the household fridges that I'm aware of use R134A, although some of them are now using butane or propane in small amounts instead of this stuff. This is the gas that's in your fridge and makes your fridge cold because it's constantly boiling and condensing. from liquid to gas, gas to liquid. When you spray one of these off, you'll feel the can get cold because in order to convert the liquid into a gas, it requires heat. So it absorbs the heat from your room, goes in here, and it boils off the liquid. The air conditioner does the same thing. Liquid refrigerant goes into the coil in your room. The heat from the room boils that off to a gas, and that's how you get the heat out of the room. And then the compressor shoves that gas outside at a higher pressure and allows it to turn back into a liquid, which throws off the heat to the outdoors. And it just cycles around. The nice thing about your fridge is the gas is sealed inside. You're not blasting it off into the atmosphere. So it's not really a bad thing to use it in a fridge versus this, which is completely disposable and just vents it to the air. So that's air dusters, or gas dusters, probably a better term for it. You can call them that if you want, but it's absolutely in no way air that is in here. It is a fluorinated hydrocarbon, either this one. There might be others out there by now that might have lower GWPs, but this gas does not have any oxygen in it. So we hear about people sucking on the air dusters and the gas dusters to get high. Oh, it's drugs. Well, it's not drugs. But it's, number one, if you inhale that, you're not inhaling any oxygen. Okay? So that's part of what it is. The other thing is these gases are very, very similar to a lot of the anesthetics that are used for general anesthesia. So many of the anesthetics that you would get if you were going to like surgery or something are fluorinated hydrocarbons, just like this. And they have similar kinds of effects, although these aren't as strong. So that gas can go into the bloodstream, and by way of various unknown and known actions, I'm not an anesthesia expert, but quite honestly, most of humanity doesn't even know how anesthesia works. We just know it works. So when people talk about using these for recreational purposes, they're referring to inhaling it for a little bit of an anesthetic effect and a little bit of hypoxia. So that's it. Canned air / gas dusters. Dust off, ultra duster, whatever your term for it is, it's not air, even though we call it that.